Morning, guys. It is week 3. We have made it through 2 weeks of this, which is pretty crazy. And what we are going to be doing first today is talking a little bit about the test that's taking place tomorrow. Yes, our first math test online. Well, here's how it's going to go. It's going to be a normal test, and it's going to look a lot like this review that I sent to you. And what I want you guys to do is, if possible, print it off and do it just away from your computer screens, away from your phones, so we can remove from us that temptation. And I really understand how great that temptation is to cheat. But please, please, please don't give in to that temptation. I am giving you guys these basically on the honor system. As brothers and sisters in Christ, I trust you guys to do the right thing. And while I can't enforce that, I think that you guys are pretty outstanding as a whole, and I would much rather see you guys show me your best work than a lie. So please resist that temptation. And I really recommend that you take the test between 1 and 2, because that's when I'm going to be on Zoom to answer questions really more immediately. But you can take it at any time. You just might need to set it aside if you run into a question and come back to it later. One thing that you are allowed to have out, this is not cheating at all, is you are allowed to have out these formula sheets. You can also take out your surface area formula sheet if you would like that, because that has all of those area formulas on the back that you really need for volume. Other than that, if you want to have out notes, I really don't mind. I just don't want you guys searching the web for things. So thank you for your cooperation with that. Please don't be afraid to ask any and all questions. And let's jump into finding the volume on our review sheet. Now you guys can see I jumped right to the back, so that's where we are going to begin today. If you have questions on the front, I am, again, on Zoom from 1 to 2 today. Otherwise, you can email or comment below. Now here we're asked to find the volume. And when we're finding a volume of a shape like this, it means that we're going to be finding a volume that's composed of 2 different shapes that we have. Here we can see that this upper part is half a sphere. So I'm going to have 1/2 times the sphere. Ooh, can't spell, but you guys already knew that. Plus this bottom portion, which is a full cone. Now the reason why I'm writing it out like this is this gives me the formula that I'm going to be using. I'm going to be using V is equal to, well, 1/2 times the formula of a sphere. And we know according to our formula sheet that that is 4/3 pi r cubed. And we also have our cone as our second formula, and that is 1/3 base times height. And I'm actually just going to write the base as we're used to seeing that, and since it is a circular base, it's pi r squared, and then multiplication by our height, h. Okay, so the reason why I'm doing it like this is now what I can do is I can go through and I can find, well, what are my variables that I need to fill in? Well, I need an r, which takes care of the surface area, or I'm sorry, the sphere, and also takes care of the base. And the only other number that I need is our h. We can see according to our picture that r is 3, and our height of the pyramid is 4. Could you have done this all separately? Definitely. But the nice thing about this is I can now type in 1/2 times 4/3 pi r. Watch this. If you got this one wrong, it's probably this third, okay? Plus 1/3 pi, and then r 3 squared times 4. Now what you're going to get is, for the volume of a sphere, we end up with an answer of about 56.549. So 56.549 plus our volume of the cone, which is about 37.699. 37.699. Add those together and you get your overall volume, which is going to be 94.2478 approximately, and this is in cubic meters. For our second figure, we're again finding a volume that's a combination of two different volumes. So the volume of the cone plus the volume of the cylinder. So let's get those formulas down on our paper here. V is equal to, well, we have the full cone here, which is going to be 1/3 our base, which is pi r squared, times our height. And I'm going to call this height 1 because you notice we are going to have two heights here, one that's a height of the cone and one that's a height of a cylinder. In fact, I'm just going to find that height right now because I know that that can easily become problematic. So our first height is equal to 6. I'm going to add to this the volume of a cylinder, which is just base times height, or pi r squared times our second height, height 2, which we know is 12 because that's the height of the cylinder. So just be very careful here that you don't mix those two heights up. They're very different heights. Okay, so now all I need to finish out my formula is find what other variables am I missing. Well, I'm missing in an r. So let's figure out what r is. Well, r here is going to be this radius. And the problem is I'm missing that as well. So how can I find this? Well, how do we usually find measurements when we're looking for a missing one? In geometry, we use the Pythagorean theorem. And that is, of course, if you see a right triangle with one side missing, you can always find that missing side. So let's use that right triangle. We know that the hypotenuse is 10 because that's opposite of the right angle. So my a squared plus b squared equals c squared is going to read 100 for that c, and 6 squared plus r squared will make the a squared plus b squared. Now when you solve this, oh sorry, not 100, 10 squared, jumping ahead of myself. When you solve this, you're going to get 10 squared, which is 100, minus 6 squared, 36, gives us r squared is equal to 64. And the square root of 64 is 8, so that means that r is equal to 8. With this, I've now filled in every part of my formula, and I can drop these values in. What I'm going to end up with is an answer of 2,814.867. I know I'm skipping a lot of the nitty-gritty details here. Just be careful when you're substituting in your h's that you grab the right one, and watch that you're squaring the r. Don't forget your 1/3 here. So type it in very carefully and you should be good to go. Don't forget your units, of course. This is in inches cubed. Next problem is about Sylvia, who had a terrible day discovering that her cement truck's valve had broken, and you can see all the contents ran out, formed a giant cone of hardened cement, which is pretty cool, but not great for her life. But she can make an insurance claim, and in order to do so, she needs to figure out how much cement is in the cone. So she worked out that the circumference of its base is 44 feet, and the cone overall is about 4 feet high. So we're going to try to figure out the volume to the nearest cubic foot. Now, since I know that we're looking at a cone, I'm just going to draw one off to the side. It can help me just kind of have that extra trigger as to what I'm looking at and what I'm looking for. And I'm also going to write out volume. And since I'm looking at the volume of a cube, I can get that, or not a cube, a cone, I can get that formula out right away. Volume of a cone is 1/3 base times height. And just like before, base is going to be our pi r squared. And our height is a distance from the apex to the base. And we're already told that our height is 4 feet high, so I'm going to take that and drop it into my formula. Now when I'm looking at this, I realize that of course I'm still missing information. I don't have the radius. But when I'm looking through my problem, the only additional information I have is that the circumference of the base is 44 feet. So what I'm going to do real quick is I'm going to just say, well, I saw circumference. And anytime I see circumference, I should think of the formula C equals pi r, 2 pi r, because that's our formula for circumference. And formulas are your friends in math. They tell you what to do. So if I know that c is equal to 44, well, that means that 44 is equal to 2 pi r. So I found my formula and I've discovered, well, now I can solve for r, because all I need to do is divide both sides by 2 pi, being very careful to use parentheses here. And we're going to end up with an answer here of, let's see, r equals 7.003. And that is, of course, in feet. So once I have that, I can drop it into my formula. So I know that my base is going to be pi times 7.003 squared. This means I can drop this back into my original formula. So in my calculator, what I'm going to type is 1/3 times pi times 7.003 squared times 4. Could you have simplified this first? For sure, but you don't really have to, and sometimes it's better not to, because your answer is going to be more exact if you don't have to multiply by the pi till the very end. So I end up with an overall volume of about 205.251, and this is cubic feet that she has dumped. That is a pretty big cone. I don't know what she's going to do with it, but I guess it's a pretty interesting yard picture. Our next problem tells us that a sphere has a volume of 240 units, and we want to find its surface area. So I'm going to start out by writing out the two formulas that I'm going to need. I'm going to need volume, and I'm going to need surface area. So I know that volume is equal to 4/3 pi r cubed, don't do squared here, and I know that with surface area, my volume is going to be, or my surface area is going to be equal to 4 pi r squared. Now in both of these, I'm going to need an r in order to get the other term. But in this case, I don't have r for either of them. So in order to find its surface area, I'm first going to have to figure out r using the volume of 240. So I'm going to actually move this up here so I have a little bit more space. And I'm sorry about the mess that's going to come from that. So when I'm looking at this, if I know that v is equal to 240, that means 240 is equal to 4/3 pi r cubed. I'm going to divide both sides by 4/3 pi, and I'm going to be very careful here with my parentheses. This is going to give me r cubed. Now careful, the cubed is stuck with the r. You can't move it to anything else, because according to order of operations, you're going to be doing r cubed before you do any sort of multiplication. Also remember that this means r times r times r, which means you can't just transfer it to the pi, which would be pi times pi times pi, two entirely different numbers. When I divide by this 4/3, which leaves me with that r cubed, I'm going to get an answer of 57.296 about. Then I can take the cubic root, or the third root, of 57.296, and remember, if you can't find this on your calculator, it is underneath math, and you can also just raise it to the 1/3 power, which means the same thing as a cubic root. So r is equal then to 3.855 approximately. Now that's really great, because as soon as I have a radius, I know I can find surface area. So if r equals 3.865, I can substitute that into my formula. Don't forget that now we're using squared. And that's going to give me a final answer of surface area is equal to 186.763. So 186.763, and this is in units squared. Please watch that anytime you're doing surface area you have square units. I would consider it wrong if it is in cubic units. Of course, you don't lose all your points, but quite a few of them. And that's that problem. So we only have two more. And due to how long these last two are, and the fact that a lot of people won't have questions with these ones, I'm going to do those ones on a separate video, so see you in just a second.